Welcome to structural dynamics class. So in this class we will study how to construct tripartite graph. So this tripartite graph is a graph which shows displacement, acceleration and velocity all on the same plot. So it is a spectrum which all three values, that is displacement, velocity and acceleration, are shown in the same plot. So that is called tripartite plot. So in the previous class we have discussed about how to construct response spectrum and its applications, its uses, and then what are the special cases of response spectrum we have studied. Now we will discuss about the construction of tripartite plot. If we look at the total stored energy in the system, that is equal to kinetic energy plus potential energy. Now kinetic energy is measured in terms of half mv square, that is u dot square, and potential energy is half k u square, half m u dot square and half k u square. So this is potential energy and this is kinetic energy. Yeah, it's something like this. And for energy to be maximum, either potential energy is maximum or kinetic energy is maximum. So E max, that is maximum energy, is equal to half k u max square or half m u dot max square. So that means what? If kinetic energy is maximum, potential energy is 0, and if potential energy is maximum, kinetic energy is minimum. So like that. So that means what? Maximum kinetic energy is equal to maximum potential energy. So if we rewrite this above equation, half k u max is nothing but SD, spectral displacement. So square of spectral displacement, that is equal to half m u dot max square. So this half m u dot max square, if I look at it, SD is here. So if I bring this m term below and strike off this to half and half, so we will get k by m into SD square. So if we take root, under root k by m is omega and SD square root is SD. So u dot max, that is velocity maximum, is equal to omega times spectral displacement. So this velocity is called pseudo spectral velocity. It is like velocity but equal to pseudo spectral velocity. So similarly we can get pseudo spectral acceleration as omega square SD. Now how do we develop tripartite plot? So it is observed that knowing spectral displacement, one can obtain spectral acceleration and spectral velocity, that is pseudo spectral acceleration and pseudo spectral velocity. Hence all three provide exactly the same information. So with this it is possible to plot all three on the same graph. And how do we plot all three on the same graph? So let natural period be on the x-axis and velocity be on the y-axis. So we plot on the log scale. So log of natural period, that is log of t, logarithm to the base 10. So log t is x-axis and log to the base 10 PSV on y-axis. So velocity on y-axis and natural period on x-axis. So we plot that. Then let's look at PSA be constant line. So pseudo spectral acceleration, let it be constant 1 C1 is equal to PSA is equal to omega square SD. So we have already seen that omega square SD. So this omega square SD, so we write in a slightly different form. Omega square SD can be written as omega into omega SD. So we already know that omega SD is PSV. So C1 is equal to omega into PSV. So this omega can be written as 2 pi by t. So we already know that t is equal to 2 pi by omega. Using this relation we write 2 pi by t into PSV. So then taking log on both sides, left hand side and right hand side, log out to the base 10 C1 is equal to this log pi plus log to the base 10 PSV minus log to the base 10 t. Then on substituting the values of x and y we get, so what is x? X is log t and then y is log PSV. So if we substitute that value, log to the base 10 constant C1 is equal to log 10 2 pi plus y minus x. So this is y and this is x. Now if we write this equation in the form of y is equal to mx plus c, so what we get from the earlier equation is y is equal to x and this values, so c1 by 2 pi. So y is equal to x plus log to the base 10 c1 by 2 pi. So this is constant. So what will happen is if we differentiate this one dy by dx, we get 1. So 1 means positive 45 degree slope. So dy by dx slope is dy by dx 1 means positive 45 degree slope. So the intercept on y axis depends on PSA. Hence PSA lines have positive 45 degree slope. So in tripartite plot, so if you take say this as t, log t, and this as PSV, so what we get is, so these lines on this, if we measure this one, so they on these lines, these positive 45 degrees lines show PSA acceleration values, pseudo spectral acceleration values. Similarly, if we plot say displacement, so SD to be constant lines, so spectral displacement is equal to C2, constant 2. So now we derive spectral displacement, that is C2 is equal to PSV by 2. So we already know that SD PSV is equal to omega times SD. So SD is PSV by omega. So PSV by omega, we can write this omega as T by 2 pi. So we write that. So what we get is PSV into T by 2 pi. Again, if we take log on both sides, so log to the base 10 C2 is equal to log 10 PSV plus log 10 of natural period T minus log 10 2 pi. So again, if we substitute x and y values in this one, so what we get is x is this one and y is this one. So we get log to the base 10 C2 is equal to y plus x minus log to the base 10 2 pi. So again, if we write in the form of y is equal to mx plus c, y is equal to, so x minus x plus this entire thing is constant. Now if we take the differentiation of this term dy by dx, so we get minus 1. So that means negative 45 degree slope. So the intercept on y axis depends on SD. Hence constant PSA lines will have 135 degree slope. So 135 degree positive slope or minus 45 degree slope, both are same. So that means what, when we draw this one, we have this measurement on this scale. This is T, this is PSA. Now if we look at the plot and spectral displacement and spectral acceleration on the same plot, we get plot something like this. So natural period is on the x-axis, velocity is on y-axis, and a minus 45 degrees line we get displacement, and plus 45 degrees line we get acceleration. So how do we read this one? So first we find out the natural period of the building or structure, and then go and straight away hit the curve, and then measure it horizontally on the y-axis, that is PSV. So we get PSV value there, and from the same point you drop onto the acceleration line, constant acceleration line, we get PSA value there, and then on displacement line, if we draw perpendicular there, we get displacement line. So like this we can measure from the same plot spectral displacement, pseudospectral velocity, and pseudospectral acceleration. So in summary, what we have understood in this class is how to construct a tripartite plot which gives all three measures, that is spectral displacement, pseudospectral velocity, and pseudospectral acceleration on the same curve.